Perfect. So welcome to this talk, modifying legacy code the right way. Well, one right way, according to me. I guess there are many, but this is a technique that I've developed over time with a few teams I've worked with to just kind of not go insane working with legacy code, which has all kinds of pitfalls. And one of the big things is that I've seen developers do, especially more junior developers, is just add more and more control statements. So that's one of the things I want to avoid, because that just adds a lot of complexity to the code. A little bit of introductions. My name is Albert Albal. I worked with Linux Foundation recently. I've worked on a few big Drupal sites, such as the Montreal Transit Authority, and a few sites that really needed to have automated testing and continuous integration. And that's pretty much become my specialty, to kind of take teams who are not doing continuous integration and not doing testing and kind of bring them to a point where they can implement these best practices. That's pretty much what I do with my consultancy, D-Cycle. This presentation is on this address here. It's also pointed to in the Badcamp website. A few more introductions, I guess, yourselves, really quickly, by a show of hands. Who are more like developers, people who used to writing code? Perfect. Okay, so almost everyone. How about project managers? Okay, and themers. Funny, last time, okay, themers, great. Last time I gave this presentation, there was also one project manager in the room, and he walked out on me because he. But I'll try to be smooth on you. So that's an electrician. I often like, when I talk about how to deal with legacy code, I like to look at how electricians deal with legacy systems, because electricians have been around for 100 years, and they really developed a technique to kind of standardize what they do and make sure that they don't go in and touch legacy systems if it can be dangerous. You see them riding around in their big trucks, and they're always on top of things, these people. But they do have one thing in common with us developers, and they have to really deal with crap like this. This is like, some client's going to ask them, so can we add a light fixture, in this room? And it sounds really simple to the untrained person, but the electrician's going to look at this and say, well, maybe it's not that simple. This is a legacy system, and the electricians have building codes. There's building codes all over the world. This is the one from Quebec, where I'm from. And it explains basically what you can and can't do to legacy systems. And it says, well, you can't have more than a certain number of circuits in a junction box. And so if you do have more than 3 circuits in a junction box, well, you can't add a light fixture. It's just you can't do it. And that's what the electrician is going to tell you. Any electrician is going to tell you that, and you can know that. As developers don't have a building code per se, we do have best practices, which are kind of loosely defined. So automated test, continuous integration server, like a known good starting point, not too many externalities when you're running your tests, small pure functions that do one thing, DevOps, and using mock objects and stub objects and things like that. But they're kind of loosely defined, and we often tend to throw them out the window when a client asks us something simple. Well, can we limit we have this list on one page. I'll show you a demo later on of a module that does this. We have a list on a page, and we like to limit it to 5 items instead of showing everything. Can we do that? And often, without even looking at the code, developers are going to say, well, yeah, sure, we could do that. It takes about an hour or 1 story point, even though maybe the underlying code looks like this. That's the call stack to one HTTP request on Microsoft IIS. So our system may be extremely difficult to work with, yet we're going to assume that simple requests are going to be okay to do. And the legacy code comes about by having these simple requests done over and over and over and over again by different people over time, and it leads to something like this. So I guess the rule number 1 of modifying legacy code is just don't do it, basically. If the code is, if you define the code as legacy code, someone asks you to change it, don't change it. We'll see later on. I think there are ways to actually introduce new features without touching legacy code, but don't actually go into these monster functions and add if statements and change things around. I think that's a bad approach, and it's going to lead to regressions. Let's define legacy code for the purposes of this talk. There's one quote I like. I could never succeed in intelligibly defining it, but I know it when I see it. That's Judge Potter Stewart in 1964. He wasn't discussing legacy code that was about pornography. But I think it might also apply to legacy code. It's like we kind of know it when it's there, but it's really hard to actually define it and say exactly what it is. For the purposes of this talk, we'll define it like this. Let's say that code with no test coverage is legacy code. And that actually comes from the book Working Effectively with Legacy Code by Michael C. Feathers. And that's, I think, a pretty good rule of thumb. If a line of code does not have test coverage, we could say it's legacy code, even though we might have written in this morning, maybe. And that's often the case. When we look at legacy code, we shouldn't think of stuff that our forefathers wrote. It's really stuff that's been written in the last week or so. So automated tests define good code. Right? Lack of automated tests define legacy code. What about all these other best practices? Continuous integration server, known good starting point, and so on. Well, I think all of these things kind of support automated tests at the end. And automated tests is really the gold standard to define whether code is modern or not. And so, well, a continuous integration server basically runs your tests every time a change is made. Because automated tests that are never run are basically useless. Known good starting point in DevOps, well, it basically removes kind of externalities, cloned databases, unknown states of servers and things like that from your test, and it allows you to have reproducibility. Small pure functions is important because we want to avoid long functions with several control statements where the complexity is a lot greater and you have lots of execution paths. So if you have a function with 1,000 possible execution paths and you're testing 3, well, you might have automated tests, but you're still not testing every possible scenario. And finally, mock objects also, we're just going to remove kind of some externalities. Let's say if you're making an API call to an external service, you might want to mock that out and make sure your system reacts appropriately when the external system times out, when the external system becomes an error, and things like that. But all of this kind of supports your automated tests, basically. Let's look at some sample legacy code, which basically corresponds more or less to the hypothetical client request to take a list and put it down to 5 items. Oops. So I'm going to show you the code. It's here. It's also linked to on the Badcamp page. So what this site we can imagine having a system, a hypothetical system, and what it does is it shows all the GitHub repos for a specific user. You might imagine a client having a system like that. And so I set it up. That's exactly the code that I pointed to on GitHub. So the Drupal user on GitHub has one repo. This is what our system does. But some other users might have some more repos. Like, for example, my own user has probably a bunch of, 30 repos here. And my client would have asked me, hey, I want to take that and have 5 instead. So I'm going to show you what the code looks like. The request sounds simple, but the code is actually really all over the place. I did my best to kind of reproduce the kind of stuff you see in legacy code. This is PHP, but it also applies to front-end JavaScript stuff and so on. So we have this monster function, right, with lots of embedded if statements. We're outputting HTML directly with the PHP. There's really all kinds of stuff going on here. And we might have determined that this is a function we need to modify in order to get our list down to 5 from whatever it is now. So what's wrong with this code? There's a few things wrong with this code. These are things I've seen quite often. Global variables used in procedural code. The arg function in Drupal, which basically gets the current argument from the current page, and that's kind of meaningless outside of the context of a page, so it's hard to unit test that. I've often seen this as well, like node IDs hard-coded, say, well, do this, except if you're on node 5, and then you do something else. I've seen this kind of thing. Lots of embedded if statements, which increase complexity quite a bit. And finally, an unmockable REST call, which you can't unit test this function because it's going to make a call to the GitHub API, and you don't want to do that during your unit tests. So how would a typical, I guess, junior programmer tackle a problem like this in a shop where we don't have accepted best practices enforced? So the way that that person would do it would probably be something like this. Okay, so basically add another if statement. And that's how we got into this mess in the first place, is adding all these if statements. And mathematically, that's going to double the possible execution paths in your function. And it's going to require that you double the number of automated tests in order to cover this function. So that's kind of the wrong approach. It's an approach that, quote, quote, works in the sense that you can go ahead and try it out. And here it says there are 30 total repos. Here are the first 5. So for demos with clients, this looks good. But you're really adding a lot of complexity under the hood and a lot of technical debt if you're doing this. So let's see what my approach would be with this kind of code. So the first thing is you can't really run automated unit tests on procedural functions. It's very hard to do because you often end up with calls to external things, and how do you deal with that stuff? So the first thing I normally do when I'm in front of a function that has like a 200-line function is I'm going to move it to a class method. Still not touching it. So how does that look for this project? Oops. So here's my procedural function that's called by my callback routine and so on. But instead of actually writing my function in this procedural function directly, I'm going to create a new class, and I'm going to create an instance of that class and call the result function within that class. So what does that look like? It's going to look something like this. So it's basically the exact same crappy code within a class, right? That's kind of the first step. And doing that is going to allow us to use the object-oriented capacities to have subclasses in order to mock certain parts of our initial class. So, okay. All right. So what do we do then, actually? So remember, here is where we added our if statement earlier. So instead of adding an if statement directly into the code, I'm going to leave the code as is. And I think the point here being is that I want to go and surgically add and remove stuff from this code. I can't not modify it because I have to modify this code. But I don't want to be adding logic to it. I want to be adding calls to external functions. So this is not that dangerous. It's not as dangerous as an if statement. There's no way I'm going to be testing all of the legacy code. However, I'm going to be able to test just this one part, and I'll show you how. So trim data is going to be in its own function. And this allows me to test that, because now this becomes unit testable. It's called by my main monster function, but this is, I don't want to test that's not what my client is asking for, that I test existing functionality that works. What my client wants is new functionality, and that's what I'm going to be testing. So how do I test this? Well, in this case, I'm going to be using PHPunit to test that exact function. So I'm going to be creating a new legacy code example class, the same one that's created in my main procedural function. I'm going to be adding defining some dummy data, defining some dummy results I'm expecting to get, and just assert that those are correct. And that actually works fine. So I'm going to show you that on Travis, which is very easy to do. Now that I've defined my unit tests, I can actually run them on any continuous integration platform, in this case Travis, and my branch number 2 is actually passing very well. There's one thing missing though here. I went ahead and trimmed the data, but I'm not adding a message in case there's more than one and more than 5 items. So this approach becomes a little bit more complicated when I want to add messages. So take a look at this trim data function, which is unit testable. And it's a pure function, in fact. It doesn't, I'm going to actually bring it a bit higher. So this is really a pure function. It's kind of the easiest thing you can unit test. It doesn't make any calls to external anything. Where this does get complicated, though, is if you want to add something like Drupal set message. So Drupal set message you can't really call from a unit test because the unit test has to be aware that Drupal set message exists and has to be aware of what it does. Let's see how we can get around that. I'm going to go back here. Get checkout 3. 1 sec. Okay, there it is. So here my trim data, if you notice, contains a secondary call, which is Drupal set message, but I'm not actually calling it directly. What I'm doing is I'm calling another method which itself is going to call Drupal set message. I'll show you in a minute why I'm doing that. In fact, if my unit test were to call Drupal set message directly, it would crash because it doesn't have access to Drupal set message. If I wrap Drupal set message around another method, I can then define a subclass of legacy code example, which I can call legacy code example mock. And that's going to override Drupal set message and kind of take internally keep track of messages which have been set. And I can then call get last message directly on my class. So it no longer needs to have access to the underlying system, in this case Drupal. Same thing with the T function. The T function is going to crash if PHPunit doesn't know about it. So I'm going to just override it here. And if you noticed in my original class, I just wrapped it around in a method. So I can override this method and just say, well, instead of calling the Drupal translation system, which we know works, we don't want to test that. We assume that works. So all we're going to do is, instead of trying to call it, we're going to very simply add some code that kind of reproduces more or less what T does, right? Because we know that T works. So this is going to work quite well, actually. We're going to be able to have a fully functional system along with a message being set, and everything's going to work fine, and our unit tests are going to pass. So this is branch number 3. So that's fine, but that's not really that advanced, because you get it. You hit walls quite fast with if you're creating your own mock subclasses of your actual classes. So here, I'm running one test. I need to create a mock subclass of legacy code example. Maybe another class is going to create another mock subclass which does something different, and it's a bit unwieldy. So I'm going to move on to another branch of my code which does away with the mock with this mock class, and we're going to actually create mock classes on the fly using PHPunit. So here our mock class is gone. Our initial class is exactly the same as it has been all along. We don't need to change that. And the magic happens in our legacy code example tests class, which itself is going to use PHPunit's capacity to build mock objects on the fly. For JavaScript, there are similar technologies. Yesterday there was a talk about the AVA technology, which does a lot of this stuff. For PHPunit, this is a great way. And PHPunit, it's not in Drupal 7, of course. So in this case, I'm just running my PHPunits on the side. I'm not even caring if it's Drupal or not. What exactly am I doing here? So PHPunit in this case, and I don't want to get too caught up in the code itself. It's more of the concept of trying to abstract out of our code things that we don't need. And PHPunit is really good at that. So in this case, we're going to get a mock. We're going to get a mock version of our legacy code example on the fly. We don't need to actually define it. And we're going to set the Drupal set messages. We're going to kind of override directly the Drupal set messages and the T functions. We're going to get mock versions of those. Where are those defined? Well, they're defined with these callbacks here, the Drupal set messages and T functions of this. What does that mean? Is that within our test class itself, we can say, well, test our logic, the logic of our code, our trim function, which we created, but just assume the Drupal set message and T do the following things. And here they are. So Drupal set message, we want that to just set an internal pointer to our last message, and T, we just want to return basically a string. And then we added another function, which is get last message here. And we're going to just return the last message that we stored internally. So that allows us to do away with a lot of the mocking that we had to set up directly, and we're doing it all in PHPunit. So again, I'm going to just clear my cache here, and we're going to see if all of this actually works and if our tests pass. Okay, so here I have someone with more than 5 Git repos, and it's showing the message as expected, and it's showing only 5 repos as expected. All we did to our monster legacy code is we added this this line. I mean, ideally we wouldn't touch that at all because it works. We don't want to deal with it. You know, but I think that adding one line, I call that surgically adding or changing stuff. If we, let's say, wanted to modify this part here, or this part here, what I would do then is extract that, put that in its own function, make sure that that function is tested correctly with PHPunit, and not care about the rest. The errors I've seen people do are mostly trying to go into legacy functions and try to modify them directly. I've seen also some companies have these grand projects to add tests to legacy code without understanding that, well, you know, it's impossible. For most legacy code, it's just not designed for unit testing. It's just impossible to add them. So you'd have people go in and start to add unit tests to those things and realize they have to move it around in order to add unit tests, and that's when they would introduce regressions to code that was frankly working fine. You know, and that's coming back to the electricians. You know, if your house is not up to code but it's working okay, the electrical code says leave it as is. You're not even allowed to touch it. If I called an electrician and said, well, I want you to bring my house up to speed, he has to redo everything. He can't just do parts of it. And I think as developers we should maybe think in the same way. I'm going to take maybe some questions now about like the basics of just kind of surgically extracting code, and maybe some more technical questions about what I showed if you haven't, things you haven't understood, or is everything good? Yeah?
I have a question. So when you're defining the mock functions like T and Drupal set message, do you have to define those for every test, or can you create like a superclass?
Yeah, well, that's a good question. So the question is, if I have 25 tests and each one of them is needing a mock version of Drupal set message, I have to define it each time. And the answer is, well, yes and no. In a sense, it's no if it's always doing the same thing. So we can have a superclass or a parent class that defines it and just have all our unit tests be subclasses of that class. And that's what actually Drupal 8 does. Drupal 8 defines mocks a lot of its functionality in superclasses, and we can use PHPunit subclasses of those classes to test Drupal 8. So that's a pretty good idea. But for example, you might want to test, you know, let's say you have a call to Drupal 8 HTTP request that you want to mock, and your superclass defines that it works, but your subclass wants to make sure that actually, you know, you want to make sure that this thing that your code works even if the underlying API, say GitHub, as it was the case yesterday, was down. And so then you would probably want to define your own version of that in your subclass, your own version of Drupal HTTP request, which, given certain parameters, is going to return just a timeout or a 404 or whatever, and just see how your application reacts to that. Because we don't often think about what happens if these underlying systems aren't working. Any other questions about that? All right. So, moving on. Yeah, this is what I was mentioning earlier. There's the electrician again. And so another rule I kind of try to impose on my on the teams I've been working with, or let's say impose with the teams I've been working with, is just immediately add unit tests and continuous integration to new code. So for example, a client comes up and says, can you change this part of my legacy system? It's often a very good idea to say, well, yeah, I can do it, but we first need to plug in the code on Jenkins or Travis or whatever, and we need to have a PHPunit infrastructure in place. This might take a few hours to do, and it might seem like a lot much for a very small change, but it's a very good practice to just kind of impose not touching any code if it's not under continuous integration. I think that has been shown to me anyway to increase the quality very much of any a new code that's added. And we've also introduced systems in some teams I've worked with where any code that's added goes through peer review, and on the checklist we have, well, does it have a unit test, or does it have a test this code? And if it doesn't, well, it goes back to do, no matter how trivial it is. And so what happens there is we're not, all of the legacy code that's already existing is still continuing to be legacy code, but at least we're not increasing the complexity. We're going to stable it down, and as bug reports come in and regressions come in, every regression as well needs to be accompanied by a unit test, and so the complexity is going to start going down if you start implementing these features, these workflows. So notice I mentioned unit tests. Unit tests, I'm really going in and testing exactly the code that I'm working on, exactly the functionality that I want. One mistake I've seen a lot of teams do is jump on the BHAT and previously simple test, which is kind of dying, with the BHAT bandwagon, and say, well, it's a buzzword, this BHAT, we're going to be doing functional testing, we're going to go around our site with a JavaScript emulator and with a headless browser rather, and make sure that everything works fine. I would say that's a great tool. BHAT's a great tool. It's extremely expensive though. If you want to test how a browser reacts, you have to install Phantom.js and BHAT and Mink, and it just takes a lot of time. And the problem is if you start with BHAT tests, you often continue doing BHAT tests. So if you have the same page and you want to see how it reacts to different input and output, you're going to use BHAT tests for all of those things, and you're going to reproduce this very, very long-winded, expensive solution for every test. Whereas what you could have done is had lots of unit tests for the actual input-output, which are lightning fast, and have just one UI test with BHAT, just to make sure the actual UI works correctly. And because we know that our unit tests function well and our UI functions well, it's going to be okay. If you do go ahead and write BHAT tests for every single input-output, what's going to happen is you're going to hit what I call the 30-minute threshold. And if your automated tests take more than 30 minutes to run, developers are going to start just ignoring them. People are going to say, oh, the tests are running, it should be okay, and they're going to pile on more and more and more regressions. So you want to keep your tests running below the 30-minute mark. And that's why I advocate for being serious about unit testing first, and then have one or two BHAT tests later on, just to make sure that your site actually loads and everything.
Question.
Yeah.
The UI test, would you also call that a simple smoke test or a general smoke test to make sure none of the basics broke? Yeah,
you probably want a BHAT test for that. So hit the home page, click on the contact link, make sure the contact page loads, fill in the contact form, make sure it actually works. In a happy case where you have an actual email, make sure it works if you put in a badly formatted email. But that's basically it, right? Mm-hmm. So very, very few BHAT tests. But I would, those could be they could be used as kind of smoke tests in effect. But BHAT can do a lot more than that. but at least have Behat for smoke tests, if not more. But really focus on the unit tests, especially if your tests are taking longer and longer to run. So yeah, I wanted to just mention the word on refactoring. Well, this is another kind of buzzword that comes up once in a while at different teams. Oh, we have this project to refactor. We have all this legacy code we want to refactor. And again, the problem is kind of jumping the gun and trying to refactor stuff before it's actually has automated tests and before it's actually monitored by a CI system. So again, first make sure that you actually surgically extract what you want to refactor from your monster functions, and then refactor those things which are tested. And if the tests pass, everything's going to be fine. So how do we sell this to people who don't, because this takes time, right? And it's really easy to go up to either management or teammates and say, hey, I want to double my development time, but we're going to gain time later on. And that's kind of very hard. A lot of us have the luxury of working in places where the entire team is behind this, but very often not. I was talking to some people who are like, well, it's all fine and good if it's free. Like everyone wants, my manager wants best practices and automated tests, but it can't cost more. And even if you explain, well, it's going to cost less over time, but it has to cost less now as well. And a lot of the approaches that I've seen to sell this to management are kind of, backhanded, like wait for a catastrophe to happen due to legacy code being in place or bad practices. I've seen teams do this stuff covertly and management not being aware that this is taking place. I've seen like some reverse psychology, make us think it's their idea. And to me, the best way to do it, if you are a developer and you want to set this up, is to really take best practices and tack them on to existing workflows. Not try to reinvent the entire workflows. Look at how your workflow is. Are you using Git? If not, you can still implement some of these best practices. If you don't have a continuous integration server, it's pretty easy nowadays to set one up. So you don't actually. You need to I think, take some initiative and go ahead and do some of this stuff that's not too expensive. And I think management expects that from developers, that as professionals, we know what's right for our code. And we're gonna, like electricians, we're not gonna want to cut corners on safety and best practices. If you are management, some managers have asked me, how can I have better communication with my team on how this stuff is set up? And there's a few things. Like, to me, the number one is really a visible continuous integration dashboard. This is one I set up when I was at CGI. So it's basically a Raspberry Pi system with a screen. It cost less than $100. It was linked to our Jenkins system, and it was really visible on the board, on the wall. So as soon as managers walked in, clients, other teams, they would see this. Oh, interesting! You have all these 6 projects. It's like transparency, right? And they're all green, and they'd be red sometimes. It would cause some interesting conversations. Like, oh, why is this red? Well, it's red because this happened. I'm working on it. Okay, it kind of reassures and it creates a dialogue that should be a lot stronger between the stakeholders. Another thing I would suggest is to give your developers the time and the resources to think about best practices. The things I've seen in my last few gigs are bi-weekly or monthly kind of informal get-togethers. Let's say the last Friday of the month, where we have someone talk about best practices, and the managers would be there, developers would be there, themers would be there, and just have an idea. Okay, what are we trying to do? Again, the idea being to have a lot more visibility around this stuff. So that's pretty much concludes the formal part of my presentation. I would welcome any questions if you have any. Yeah?
So you're obviously a big proponent of unit tests. What do you do for situations where, like in your example there, you've gone through this legacy code, you've created the unit test, you've made sure everything works correctly, and you get the results you expect, but something with that affects code somewhere else, and it's not necessarily something you can see with Behat. Like maybe it's a processing email that happens behind the scenes.
Right. Yeah.
So something like integration testing or something like that, where you would be.
Yeah. So the question is, we can implement unit testing all we want, but we can still affect code that's not unit tested and create some regressions there. And the answer is yes, of course. And you're right. This is not a guarantee that stuff is going to work, because a lot of this legacy code example, I really scratched my head to come up with all of this stuff. But it does come from experience. But I think there's a lot worse out there. And sometimes you really have no idea what's going on. And sometimes you have external systems that are depending on your code in a way that you have no idea. And it's going to break things.
Right.
I think there's, as soon as you go ahead and touch legacy code, things are going to break. In my experience, if you do it this way, things are going to break a bit less. Probably a lot less even. So what do I do when that happens? I guess setting up this kind of a workflow in the teams I've worked with, and it's really a interpersonal thing. It's really a psychological thing. It's really like getting together. It's a human thing. Making sure everyone on board, be it themers, developers, managers, understand that this is the way we're doing things now. And if a bug comes in because of this, we're going to put that bug in the same process, figure it out, unit test that, and so on. So it's happened that fixing one thing is going to break another. To be honest, it hasn't happened that often. If you really try and add one-liners to existing functions, and you try not to modify anything else. If you're replacing code in existing functions, take that code out, surgically remove it, figure out exactly what it does, test all of the scenarios. I mean, very often it's not going to affect, it's not going to create regressions, but I think you have to expect that. It is, after all, legacy code. Any other comments or questions? Yeah.
So, do you have a recommended workflow for like when you're developing a custom module? And so my understanding of how Drupal 8 works is that Drupal 8 has all these things mocked for you, but if you want to run your unit test just on the module, can you do that and not in the context of a site that's running Drupal, like you're working on 5 custom modules, you want to unit test each one of them?
Yeah, you're talking about Drupal 7 or Drupal 8?
Either one.
Yeah, so Drupal 8, does have some great mock base PHPunit classes, what I'm looking for. So the basic PHPunit class where you're just testing your code and you're mocking stuff like, T and that kind of thing. And then you have base classes which are the browser test class, which basically allows you to simulate calls to the browser. So it creates a very minimal Drupal installation for you in memory, really lightning fast, and you can actually run tests based on request-response Symfony objects. And then there's the kernel test, which mocks the database itself. So if you have database schemas and if you want to make changes to the database, you can have an in-memory, lightning-fast mocked version of the database, and you can test that. And I would actually recommend all of those methods. Drupal 8 core still has a lot of simple test in it, which I would maybe recommend less because it's very slow. So it does have a lot of the tools you need. What I do with Drupal 7 sites, if you notice here, I'm just going to show you really quickly. So Drupal 7 doesn't have PHPunit shipping with it, and I don't want to install a PHPunit kind of glue code. So what I'm doing is I'm basically just running PHPunit straight out of the box. So as you see here, my PHPunit class is extending just the PHP unit framework class. And then to run this, I just have a unit test.sh, which basically runs it in a Docker environment and then kills the Docker environment after. And all of the PHP unit kind of information is in the Docker environment itself. So you can do that. And I found that for Drupal 7, that's what works best for me. And what I like to normally have is one simple test for Drupal 7. Not many, because every time you run a simple test on Drupal 7, it kills the entire site and builds a brand new one. It takes a lot of time. So one kind of smoke test that just makes sure that you can hit the page. It's not going to give you a white screen of death. And for Drupal 8, I think one bhat test would make sense for a module. But again, if it really depends on like what type of module you're writing. If you have lots and lots of JavaScript code, you might want to unit test your JavaScript code, but you might also want to have a few more Behat tests. I think as long as you keep your tests under half an hour, you're probably good. People are going to continue looking at them, and they're going to continue being relevant.
So actually, if I guess to follow up, so what you described for Drupal 7 would work if you didn't have a Drupal site. The
Yeah,
unit test
exactly.
would work if without Drupal, but when you're working in Drupal 8 and you're depending on Drupal 8 providing the mocks for everything,
Right.
you actually have to run that in the context of a Drupal 8 installation.
Yeah, you run it from the Drupal 8, from the base of Drupal 8. You think you run Composer, Vendor, PHPunit, and then you put your PHPunit XML file in the base of your, I think, tests, I forget exactly where, in the base of your test folder, and that's going to load all of the PHP kind of mocking, the PHPunit Drupal 8 mocking stuff. And so, yeah, so that you would run directly from your Drupal installation. Whereas in Drupal 7, what I've done is I've just kind of ignored Drupal 7 and just run the PHPunit tests on my classes.
I guess as a follow-up to that, if your module is in its own Git repo, but you need to load in Drupal to run the test, is that something you would just wire up in your CI to pull a Drupal repo and then inject your module into that?
Yeah, well, I'll show you really quickly one that I've been working on as an example code. Let me just grab that real quick. So I have here a questionnaire module, and so basically my script unit tests, okay, is going to run in a container. So as if you notice, this is basically a module. It's a Drupal 7 module. I'm going to make it a bit bigger. So it's basically a Drupal 7 module. I don't have Drupal 7 installed anywhere in here, but in my Docker file itself, I'm starting from the base from Drupal 7 Docker file, which itself is going to run everything. I'm going to install Drush on there. I'm going to put Code Sniffer and a few other like development modules like devel and admin menu and things like that in the Docker file. It's not anywhere in my repo. And then running my tests is going to run the tests directly on my my PHP my Drupal 7 Docker file. If you're doing it this way, you might also want. I'm trying to make sure that I'm right about this. Yeah, create dev. So what you're going to want to do, so you're probably going to want to, ignore most of this. This is the important line here. If you want to run your Drupal 7 site in a Drupal 7 Docker container, you're going to have to create a MySQL container first, and then you're going to link, when you create your Drupal 7 container, you're going to link that to your MySQL container, and then you can just start running Drupal within those two Docker containers, which are defined in your Drupal 7 module, and that's how I would run tests. You can also run tests the traditional way, which is with the Drupal.org QA system, which requires simple test. But simple test is very limited. It doesn't allow mock objects on the fly and things like that, which I've gotten used to. So I rather do it this way and set it up to run on Travis CI, which is, to me, provides a lot more fine-grained capacity to run tests than simple test does. All right. So any more questions? Feel free to, yeah?
Is it faster, your method, than running the simple test? Is it a lot quicker to run the tests?
Well, I'd say if you're running simple tests, unit tests, it's probably as fast, in my experience. The thing with PHPunit is that really differentiates it is just all the PHPunit functionality, such as data providers, and especially mock objects on the fly, which simple unit tests just don't do. So if you have like 5 different ways that you can override your base class, you have to define 5 kind of mock objects, which you can do. I mean, it's probably easier to understand for people who haven't done PHPunit, and it's not a question of speed at that point when we're talking about simple test Unit tests. If you're talking about simple tests, functional tests, then that's really, 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 really slow. And I would advocate against using those, except maybe one in your project. So, and once you have your Docker containers set up, they're cached, so it's really very fast to run your tests. So, anything else? All right. Well, thanks for joining me, and have a good lunch. If any other questions, you can feel free to come up and join me here. Thank you.